Hey there, this is Max Doolin. This is the BRISC Challenge 1 from the 6th year of the Spokane Cyber Cup. This was written by Josh, I believe. So, BRISC, or the Best Reduced Instruction Set Compiler, is a challenge where you need to learn about how ISAs or instruction set architectures work. The idea is we have some assembly that's in a really basic form, and we're going to compile it, decompile it, and do lots of different shenanigans. So this is going to serve as the overview video of how the instruction set architecture works, and then each video after this will just have the solution for how the challenge works, and that's it. Cool. So if we can get this rendered in Markdown, we can see it a lot better here. So each one of these instructions is all there is. There's only 13 instructions, which really isn't that many. So we have two key concepts, though. We have the instruction, and then we have the X and the Y that are being used. For instance, here's what a instruction potentially looks like right here. The classic one is add. So these values are either going to be memory addresses with 1 byte, or they're going to be immediate values. And it depends on the instruction depending on which type it is. So for instance, str stands for store. I don't know why that jumped over there. Str stands for store if we look in here. Yeah, right here. Cool. So it's saying we're going to store a value of x, or a value of y at memory address x, and it's always going to be xy. So this is saying we're going to store memory address, or we're going to store the value of 0 at address 0. This is going to store the value 100 at the address 1. And then it's going to do various computations. It can jump to change the control flow. It can do compares for if statements. It can do basic arithmetic like adding. For instance, with adding, it's going to add memory address 2 to memory address 0, and then it's going to put the result back into memory address 0. So the first part of this challenge is just understanding how this works and being able to read these programs. Now we have an idea of how this works. We have an instruction that does a particular thing. Most things operate on memory addresses besides store, and which has the intermediate value. And we can read the instructions. So the first challenge is just BRISC math. I love math. Math in BRISC, yes please. For this challenge, you're going to be executing basic BRISC instructions yourself. So read the spec. This challenge requires to interact with netcat in order to do this. So the goal is to make sure that the student understands how to read this architecture that Josh created. So I have this set up locally. So I think that port is currently wrong on this local setup, but that's fine. So this is what it looks like. So it gives you some basic information, and then it gives you a program as an example. And it says we're going to supply you 3 BRISC programs, and you have to do the math correctly. And if you do the math correctly, then we're going to say, hey, you know what you're doing. You can read this and move to the next challenge. So for this one, it's going to be store 7 in address 14, store 19 in address 15. And then we're going to add those together. So 7 plus 9 is going to be 26. And then we're going to add, which is done here, that's put back in 14. And then we're going to do the result of that divided by 12. And then it's going to be integer truncated. So we can do this real fast in Python just because I'm lazy. 7 plus 19 divided by 12. So that's going to be 2. And now we have the right answer. So we have to do this over and over again until we get the flag. I wonder if I could split this. Does that work? I can't do that. Okay. So we're putting 7 register or memory address 19 and 2 in address 27. And we're multiplying those. So we do 7 times 2. And then we're going to store 1 and 17 divided by that. So then divided by 1. And then we're going to store 9 and 22 and then do the result of that division, which of course is just going to be 14 because from before, times the 9. So we do times 9. And then the final part to it is we're putting 16 into memory address 9. And then we're going to subtract 19. So 19 was the result of the previous operation. So then it's just doing minus 16. So we end up with 110. Cool. All right, so that's that. Now the final one we have, we're going to do 10 divided by 3. And it's important to use the double slash here because it's going to do exact integer operations. There's no floats or decimal numbers represented here. So 10 divided by 3. Then we're going to add 10. And we're going to subtract 16 was put in there. So now we're doing 16. So we're doing the result minus 6. And then we're doing times that result times 13. So we're putting 13 into 21. So then we need to multiply it by what that value was. And then we're doing subtract 30. You don't need to do this. I'm just doing it to make life easier. So subtract 30. Or sorry, subtract 6. It's memory address 30. And then we're putting 6 again into 30, and then we're adding that. So minus 6 plus 6. All right, that's 91. And we get the flag. So that's how we do that one. The key thing is to understand the specification, understand the format, and then be able to execute these themselves. These programs aren't that big, so you just got to write the math down. You'll figure it out. Cool. See you in the next one.